In this video, I'm going to walk through some common data manipulation and feature creation tasks. We will be using the same bike warehouse wholesale company data as in the last video, and we will be using the tidyverse set of packages. So we first start this up, and there are lots of options for manipulating data. We're going to stay within the tidyverse. These same sets of packages work well for lots of tasks, but there are other ways, and sometimes less coding, ways that take less code or ways that run a little faster, but we're going to stick with the same framework, and it works pretty well. Another sort of warning or reminder here is every time you run something, you should be thinking about what your data should look like after you run the task. So I'm going to do this throughout as we do make some change and then go check and see what it looks like. So I'm going to save the data frame as a different data frame. This way I don't have to keep rereading it in if I make some mistake. We're going to first start with the stringr package, and the stringr package allows us to work with text. And let me show you sort of what I'm going to work with here. There are these products here that have text in it. We could also use customer because it has text in it. There are a few others that we could use the text aspect of it, but I'm going to work with the product column here and do some text extraction with it. There's a lot more that you can do with text than we'll do here. We're just going to do the very simplest functions. If you would like to know more about how to work with text, I left some information here for you. So the stringr package, there's a Wikipedia article, and then the book we've been working with it has a section on working with strings. So text is another a way it's stored it's called strings. So there's a lot of information there, and you can try lots of different things. I just want to introduce you to it. So the first thing I'm going to do is get a unique list of product names. So remember, I'm creating a new object and I'm calling it prod list. How I'm creating that is assigning to it from the DTA data frame object, which I had up here, and then I'm continuing on, and I'm getting only where there is a distinct product. So I look over here in prod list, and it gives me a unique set of products. So you can see here it has pumps, different types of bikes, pads, different two kits, a first aid kit and a repair kit, helmets, t-shirt, water bottle stuff, okay? So let's say I wanted to group products into categories, and one of those categories is different types of bike. So we don't have a category for products, so we're going to create one. Well, all of these bike ones, see it says bike in the product description or name. So let's try that. So I'm going to overwrite the prod list data frame, and I'm going to create some new columns, which is mutate. And these are the different columns. I'm just going to try different things so you can see how these work. So string detect, str_detect, that is the function for finding if some pattern of text works. Notice as I hover, it gives me some ideas about how that function works. And a lot of all of this here is just standard stringr language. So it's not something you have to memorize and know every time. It's just something, for example, when I use it, I just copy and paste this outline, or I look at what the hint gives me. Okay, so I'm going to use the product column. So notice in prod list, even though there's only one column, there is still a column that says product. So I'm going to use the product column, and string detect means find if a certain pattern exists in the data frame. There are other things you can do too. So if we go look at this stringr website, it tells us different things. Let's just look at the cheat sheet. So notice it can find things. So detecting, string detect is what we're going to use. You can do other things like that. You can extract. So string extract is to take out something that that matches the pattern. Other things here, truncating, trimming, other things you can do. You can replace something. So take some match and replace it with something else. That's the string replace. So a bunch of things you can use here. And we're not going to go into them, but regular expressions are ways to match combinations of or types of characters or numbers without specifying exactly what it needs to match. So for example, if you want to match any type of character, down here you can see any word character. You could use this \w, and that would match any word character. Similarly, if you want to match anything, this dot would do that. Some options like this to match patterns rather than specific strings, and you can mess around with that. Okay, so string detect is to find a pattern. Here, product is the column. There are lots of ways to do this, but this is the most standard that I think works easily. So regex is a regular expression. That's what's described here in the Wikipedia article. And that means you can put patterns and different functions in there. And then here, one of the options in the regex part of the function is you can ignore whether it's uppercase or lowercase. So as we look back here at the list, notice bike is the B in bike is uppercase. It won't always be that nice. Sometimes it'll be uppercase or lowercase. Sometimes things will be spelled incorrectly. We have sort of a nicely behaving data set here. But I'm going to ignore the case, and notice I have a lowercase b. That's just to show you how it works. And in these quotation marks is the pattern that you're trying to match. So here I just have bike. I want to show you a couple of things. So I'm going to change this for just a second and only work on this column. So notice if I do prod list now, I have something here that says, just does it find bike? That's the string detect, false or true. So true, it found bike in this one. It didn't find bike in this one, so that it just is looking for that pattern. Well, we could change a couple of things here. So what if I put in just find a word character followed by IKE? Well, there aren't too many words to do that, so looks basically the same, right? So bike, not these other things. So that's how you start sort of introducing patterns rather than specific words or something like that. All right. So notice it comes out true or false when I do this string detect. I can change that if I want to be numeric. So here all I did was change this as.numeric, the new byte column, but what that does is change it to the trues to ones and the falses to zeros. Okay, so, and I created a problem because I've got 2 commas there. So if I just run this part, and notice I'm only highlighting up to this point because otherwise I would run everything else. Notice now the bike true or false is still there, and it switched falses to zeros, trues to 1. Okay? So it's working how I think it should work. Now let's do something similar just so you can see. So what if I want to find in here things related to water? So here we have water bottle and water bottle cages. So now I would have bikes and the water bottles taken care of. I'm going to do the same thing for safety. So here I'm going to, anything that says pads or helmet. So this is going to be knee pads, elbow pads, and 2 different types of helmets. This forgot what it's called. The bar here is an or sign, so pads or helmet is what it's saying here. So if I did pads or helmet or bike, then it would also include bikes. So this is kind of getting us into different types of patterns. And we're going to do, this is the exact same thing as up here, so I just copied and pasted this part and changed the bike to pads or helmets. And I just changed this to as.numeric, so instead of doing true or false, it'll output zeros and ones. And then the last one, this is if-else function, is if it meets a certain criteria, then give one answer. If it doesn't, then give another answer. This is just like the if statement in Excel. So here's the criteria. So if bike numeric, which is what I have here, is equal to, remember we need two equal signs, is equal to 0, that means it's not a bike, and water in is equal to 0, not water, and safety is equal to 0, not safety. So meaning if it didn't match any of these criteria, then comma, what do you output? That's the if part of it. Comma is what you output if it is not that part of it, so then 0. If I hover over here, it shows you the setup of the function. So test is the logic. Yes is what is the output if it is true. No is the output if it's false. So I can run all of this. And now I've got a set of dummy variables. These are called dummy variables if it's 1 or 0, 1 meaning yes, 0 meaning no. So I've got a set of dummy variables for bike, water, safety, and other, which now covers all of the products. So I could create different categories, or I could summarize things based on these criteria. Instead of doing each bike separately, I could have all bikes together or something like that. Okay, so I set this up, the stringr part, just so we could think about the next steps that we're going to do. So we're going to do a few types of data manipulation, and really it's just summarizing the data in different ways so that we can use it to answer different questions. So I've just listed some possible ways that we might want to look at it. I'll set some of that up here. So for example, we might be interested in the product month or the customer month. So meaning our data is output as for each product there's 1 month of data, or each customer there's 1 month of data, or each sales organization there's 1 month of data. Notice if we look at it now, it is each transaction. So this, we have a transaction for this customer, for this product, on this day, and what they purchased. Well, we don't always want to know information by the transaction level, so we're going to summarize it in different ways here. First, we have US dollars and euros in the data set together. So I did a simple exchange rate, and of course, exchange rates change over time, so this isn't exactly right, but I wanted to make it simple here. So every, the euro is worth more than relative to the US dollar, so 1 euro is 1.09 in US dollars, at least when I looked at the exchange rate. So this is a new syntax here, so we have mutate, creating a new column, and I'm overriding in the DTA data frame. Case when is like if else, but you can have a long list of different conditions. So the function is case when, and it gives this information here that sort of helps you understand it. I don't find this terribly helpful, but you could look at that. So notice case when is in parentheses, or everything is in parentheses here before we end the mutate function, and what we have to do then is list all of the cases. So if these are exhaustive, this is how you do it. I'll show you one more thing later that we can alter this. But we first list the condition. So here, when currency is equal to US dollars, then, so this tilde sign is how we then assign what the value is going to be. So currency is equal to US dollars. The value is going to be whatever net sales is at that same point. That's because we're going to change it over to US dollars. So notice I have net sales US dollars. That's what we're going to try and change it over to. When currency is equal to euro, then what we're going to set it to is net sales times 1.09. So run this. We should have a new column that says net sales US dollars. Whoops, I opened the wrong data frame. At the end, we have net sales US dollars, and notice for net sales, when it was a euro, it's slightly more in terms of US dollars. If we have US dollars, then net sales 2498. So it didn't change it when it was, the currency was US dollars, it did change it when it was euros. All right, so that's how to change something by different conditions within a column or within different rows. Now let's go ahead. The reason we had to do this was because we can't summarize US dollars and euros together because they're not the same currency values. And we may do that at times just to demonstrate how to make a function work like we did in the last video, but now we want to be a little bit more careful here. Okay, so let's create 3 different types of data frames. This one is going to be the product month level, this one is going to be the customer month level, and this one is going to be the sales organization month level. And it's not really that difficult, but here we're going to group by. So for each group of product, year, and month. So notice I didn't have day in here because I want to take each day and aggregate it up to the month level. And I'm going to summarize, and how I'm going to summarize is this net sales US dollars. I'm going to add all of that up for that product for that year and that month. So the total sales will be a new column that is the sum of all the sales for each product, each year, and each month. So if we run that, we should see a data set that looks like that. Notice there are 836 observations instead of 369 or 36967. And here we have air pump in 2008, January. There were $3,500 in sales for that month for air pumps. All right, and we see similarly for different products. Notice here, this is individual products, so it's not like where we aggregated, where we were trying to find all bikes. We'll come back to that in a little bit. This is each individual product. So similarly for customer, notice the only difference here is that we're grouping by customer, year, and month. Everything else is the same. And same thing here for sales organization. So we can run these. Notice for the sales organizations, there are 240 observations. This is Germany North, 2008 January. This is their total sales that they had. For customers, customer is Airport Bikes, January 1st. This is the total dollar value of sales that they had or that they purchased from the wholesale company. All right, so these are different ways to think about how to organize data. And the reason we might organize data differently is because we want to answer different questions or see something different with the data. Now let's go into options for creating different types of features. So features would be a column in the data set, and that column might be structured different ways depending on either what we want to know about the data, or if there are outliers in the data, or the column value is skewed one direction or the other. Lots of different reasons we might want to structure things differently. We're just going to go through different approaches to doing things without talking about why here, just so that you can see how to do it. So the first thing we're going to do is transformations. I will briefly show you why we might do this, but then we'll talk about it more in a future class. So here, this is the profit margin data set and total sales. And I'll say this, but we're not going to use this language too often. This is taking the profit margin data set. The dollar sign says look within the profit margin data frame and get the column total sales. And this hist is the histogram. So you can see down here a histogram comes out of total sales, and this is called a skewed distribution, meaning there's lots of data over here and there's very little data over here at the right. And by data meaning number of observations, there are a lot more observations in this range, but there are some. The reason the data frame the graph goes out this far is because out here there are a small number. You can only see a line here, but there are a small number of observations that have really large total sales numbers. So what might we do to change the distribution so that it tells us the same order of information, but it doesn't have these large extremes? And the reason this might matter is because, for example, a lot of techniques in data analysis rely on means or something like a mean, and these large extremes are going to determine a lot of what you find. So maybe we don't want that. Maybe we want to know also what's happening at the lower levels. So we might change the distribution a little bit. So how we do a transformation is just, there are lots of different options. One of the most commons is a natural log. So in R, this log is, the default is the natural log. Of course, you can change the base there, as you can see. I'm just going to take the natural log of this total sales number. You can also do power transformations. So this is taking the square root, so the power of 1/2 or the power of 1/4. There are, of course, other transformations, but these are some of the most common. So let's see what happens if I, from this product month data frame, what happens, and I called these transformation 1, transformation 2, transformation 3. Notice with the first one, the log of total sales, now we get something that we don't have the large outliers. Of course, this introduces something else strange where we have a bimodal distribution, meaning there's a clump here and a clump there. We may or may not be satisfied with this transformation, but it gives us an option. Each of these gives us another option. So the square root doesn't really take care of the extreme values. We still have a bunch out there. It's less than it was before, but then we can do the to the power of 1/4. Similar. So this is, maybe getting closer to a normal distribution. We're a long ways from it, but the extreme outliers aren't there. So we can think about different ways to alter the data to, come up with different answers and to deal with outliers in different ways. Notice if you take a natural log, though, of a negative number, that's not going to work. So this only works if you have positive values of the thing you're trying to take the natural log of. Okay, next, so other times we might want to standardize data. So meaning if you have, let's say, one customer or one product has really large sales numbers, the other has really small sale numbers. For example, if we're comparing on here air pumps versus bikes, the price of air pumps is much smaller than the price of these bikes. So maybe let's say we want to make them comparable, then we might want to standardize the prices or the total sales numbers across the different products. We may not want to do that also, but at times we may want to make things comparable. And there are different ways to do that. I have two here for you. And the question you have to come up with is, how do I want to standardize it? So do I want to make each product over time comparable to each other product over time? Or do I want to make each month comparable to other months? So I might standardize by year and month here. I might standardize by product, which I'm doing here. There are lots of choices, and the data will determine how you make those choices. But let me walk through what I'm doing here. So the first is to group by the product. The reason we have to do a grouping, unless we're doing this for the whole data set, is I have summary functions in here. So I have a mean and a standard deviation and a min and a max. So you have to tell it over what, along what dimensions to summarize this. If it's not grouped at all, it'll do the whole data set. So this first standardizing is, the main part is I'm standardizing, I'm dividing by the standard deviation. So products that have really large standard deviations, meaning maybe you buy that for a product, you buy lots in 1 month and little bit, small amounts in 1 month, large amounts in other months. Or you might have products that they're just consistently purchasing that. To make those comparable along the lines of standard deviations, we could divide by standard deviation. We also have the mean. We're adjusting for the mean here. So total sales minus the average total sales. The reason you might do that is if you have products that have really high mean values versus really low mean values. So in this case, comparing bikes to air pumps or something like that. So this would help get rid of the mean value differences. Standardizing would get rid of the variation differences. So this is a standard normal variable now. So I forgot what I was going to say there. So, but this is a typical way to standardize. Notice by using the mean and the standard deviation, this will depend on if you have outliers in there. So if you have outliers, that's not necessarily going to fix it. So one possible way you might do this, combining these things, let's say you take the log of the total sales and then you standardize. That's also something that you might see. Okay, the second standardization, I think this is more common in machine learning applications. Subtract the lowest value, and so you're trying to set the range to be the same. So this is sort of like the mean adjustment, moving this down. So now the total sales minus minimum will set the lowest value to 0, and then max minus min is the range of the data or the column. So now products that have really large ranges, from a really large to a really small, it'll be shrunk down to be the same. So in effect, this is doing a similar thing to standard deviation, but it might give you a slightly different picture. So two common ways to standardize the data. So now we look over here in PM. Now we've added we have these transformations. We also have these two standardized values. And what do those look like when we plot those? Well, standardizing by product, this worked similarly to doing one of the transformations, the raise to the 1/4. And standardizing the second way, notice it's a little flatter, but gives you something there as well. Okay. So as I mentioned, we could standardize along different dimensions. So here, what if we wanted to do by year and month rather than across products? This might be if some months there are just lots of sales happening and other months not as many sales happening. So for example, in many retail operations and sales, this happens, right? Like Christmas sales are much bigger than other times of the year. In this data, I don't think we have much of that variation. So really, we're going to be concerned about a cross-product variation, but we can look and see what this does as well. Notice that by year and month, does something to it too, but not quite the same idea. Why I think these lumps here now happen is because these are different products. So different ways to standardize. Let's deal with some extremes. So let's go by we're going to use the data frame that is now the sales organization data frame and look at the total sales by organization. Similar skewed distribution, right? We have some large outliers. So there is an organization in some months that is selling, around 2 million in in product. There are others that in months that are selling much less than that. So, maybe we want to compare across, we're trying to compare sales organizations. So there might be lots of ways we might think about that. But let's say we think these really extreme ones were just unusual. Like, for example, that particular month for that organization, the wholesale company wrote a contract with a particular sort of, like, let's say, other big corporation or something to buy all of their bikes. And we don't think this is really a fair comparison because it's not something that was done at the sales organization level. It was done at the entire company level, some sort of thing like that. Let's say we don't want it to be we don't want the comparison. We want the comparison. We want to get rid of that extreme outlier. So let me just go through a way to deal with those outliers. And this one is called winsorizing. We could just delete those months. We could change those months. Or if it was an error, we would go and fix the error. But let me just go through this, how we might do this. So I'm going to create a new column. Notice I'm ungrouping because I'm going to do it on the entire data set when I do a summary function, which is this quantile function. But we could, do this by sales organization or by year, month, or something. So we're going to create a new column. We already introduced this case when situation or function, and I'm going to call total sales adjusted extremes. So how am I going to do this? Well, I'm going to look and see, label these that are really extreme and change those. So here I'm going to, when total sales is greater than the 95th percentile, so this quantile is does the percentiles in the column, and I'm going to do it in the total sales column, and I'm going to select the 95th percentile. So this will give us a number, and what that summary number is the 95th percentile of the total sales column. So when total sales is greater than the 95th percentile, so meaning when total sales is in the top 5% up here, then what do I do is set it to, so that's the tilde here, and here I'm setting it to the same thing, the 95th percentile. So what it's going to do is take these that are in the top 5%, move them down just a little bit to be at the 95th percentile. So I've only got one condition here, notice. That doesn't cover all scenarios. So if we have a leftover scenario, you can do this true and tilde. So that means if you've gotten to here and all the other conditions that might be possible are true, then we set it equal to total sales. So it's going to apply these conditions. So if there were more conditions, it would go through each condition, and then whatever is left, it'll set to this. There are some other ways you can use this as well, like how to format whatever that is, but we won't worry about that. So we could do this in a similar way. So case when, if total sales is greater than 1 million, we're just looking here and saying, there are a lot out here, but more than 1 million doesn't happen very often. Then we're going to set it to some arbitrary number. So I'm going to set it to 1,000,001, and otherwise set it to true sales. So let's go ahead and look at what this does. So we've got at the top, notice I have 1,000,001. Those were the largest values that we set. And here, notice we have some that are the same number here. That's because any that was really extreme. So notice it was more than that. 1,783,747. Now that is set to the 95th percentile. Okay, so what does this look like in a histogram? Notice it's squeezed in the extremes there, and squeezed in the extremes here. Notice now we've got a lump on the, like lots of observations out here. That's because it took everything that was bigger than 1 million and moved it in here. So just some options, not necessarily, something you should or shouldn't do, but things to consider. Let's do another thing here, and this, let's say what we want to do is know which sales organization had the largest or the highest sales each month. Well, we can do that by ranking them. We only have 4 organizations here, so it's not really that difficult, but if you had hundreds, maybe that would be useful. So, or sometimes we just want to, instead of using a distribution that has large outliers, you can just use the ranked value. It throws away a little bit of information, but it might function better. So we group by year and month. So this is each year, each month. So each month I want to know which organization had the largest sales. So I'm creating a new column, month rank. This is by using the rank function. And we're ranking the thing here, and there are some choices here. Let me walk through this. So total sales, I have negative, so that's going to rank in a descending order, meaning the largest one is going to have 1, and then it's going to work its way to the smallest. And when there are ties, you have to tell it how to assign that rank. So there are a few different ones you saw here. So you can use the average of the ranks, the first, the last, random, max, min. I think min is the gives the easiest to interpret one, but you could do sort of any of those. At times it'll make a difference, other times it won't. So let's do this one here. And now notice at the end we have these ranks. So let's look and see which one. So notice 1 here is the largest value of sales in that month. And so the top selling organization in November of 2008 was Germany South. Now look what happened. So let's look over here, 1, 1, 1, 1. So these are all the top ranks until we get down here a ways. Well, notice what Germany South got it in 1 month, November 2008, then it was US East the whole rest of the time. So this this wholesale company seems like it is primarily run out of US East. Next comes in Germany South, which is usually second, right, except for the one time it was first. And then we've got the other ones that maybe bounce around a little bit more. Okay. We already did some dummy variables. Let's do a different one. What if we just want to, back to the sales where we have large numbers of sales. So an organization had large numbers up around 2 million. What if we just want to identify a sales organization any month when they had at least $1 million in sales? So let's say that's some benchmark that they're trying to reach. And if they reach more than $1 million in sales, they get some sort of bonus or something. So we can use this ifelse function here. If total sales is greater than $1 million, then set it equal to 1, otherwise set it equal to 0. I'm calling this mil. And we look in here, and we have something that shows 1 anytime it goes over $1 million. Okay, so then different dummy. Now, what if there's our missing values? Well, in our data set here, we don't have missing values. But in lots of data sets, you'll have data that isn't completely filled in. So what are ways we might deal with this? One of the ways is to only take observations where there isn't missing data. Other times that'll throw out a lot of your data set, so you don't always want to do that. So another way is to just create a dummy variable to tell you whether it's missing or not, and then set the missing values equal to something. And we'll do that here. So I'm going to create some missing values. So first, I'm just going to create a new data frame. This is sales organization monthly 2. And I'm going to change total sales. And these are the rows. So wherever in the 5th, 35th, 74th, and 99th rows, set it equal to missing. And in R, one of the missing the most common missing indicator is NA, or missing value. So I go here and notice in the 5th row, missing. Okay? So What do you do with that? Well, if you tried to add that up, so let's just do notice it gives you missing because you can't add up missing values, so you have to deal with that. That's where this na.rm comes in, or you remove them or you do something to them. So let's look at some of the options here. So here, creating new columns, miss, I'm setting a missing dummy variable. So ifelse, so if it meets these conditions, then it's going to be 1. If it doesn't meet these conditions, it's going to be 0. What are these conditions? Well, if it is.na means it is missing. So then if total sales is missing, then set it equal to 1, otherwise 0. So that'll be the first thing. You'll see a dummy variable for 1 when it's missing. And we have to do something with those missing values unless it is a method that allows missing values. So here I'm going to do total sales, like fixed is what I was thinking with F. So then case underscore when, so when it is missing, set it equal to 0. And so we're just assuming that month where it was missing is they had 0 sales, and then otherwise set it equal to total sales. So that's going to fill in with 0 and give a dummy variable to tell you that it was filled in with 0. Another option that sometimes we might want is to set it equal to the mean. So that's all this is here. So case when, if it is missing, then set it equal to the mean. Well, notice when I do the mean here, I have to remove the missing values. Otherwise, it won't create a mean. It'll give me a missing. So, so this is when it is missing, set it equal to the mean of those that are not missing, and then otherwise total sales. Okay, so we run this. Notice in the 5th row, it's missing. So then what has happened here? Well, we've got a dummy variable equal to 1 because it was missing. Here we set the missing value to 0. Here we set the missing value to the mean of all of the observations. Okay, so different reasons for different things. I just want you to see how to do it. Another we can do is come up with classifications. So classifications would be different types of things. So here, let's do it with the products. So what I did here, type Q, is just take the data frame, and this is just copying and pasting what was up there before. So remember, we have a bike dummy, a bike number dummy, a bike true false, a bike number dummy, water dummy, safety dummy, and other product dummy. And then you could then just add these other things in there, but I did another mutate function so you can separate. This is just a copy from above. This part is going to create a new column based on this. So here we're going to create a new one, a new classification column. I'm going to call it prod type for product type, and we're using case when here. So if it is the bike in is equal to 1, then we're going to call it bike. If it is water in equals to 1, then water. Safety in equals to 1, then safety. Other equals 1, then other. So then if we just run up to here, notice I'm not running the pipe function because that'll tell it to continue. Let's look and see what that data frame looks like. Type Q. And in the last columns, we have these variables that we just created, and that is bike is equal to, or if it's a bike, it's 1, right? And all that stuff we saw. All of these at the top are the air pumps, so those are just all 1s. And then it gives a type over here. So we have other, of course I went to other, then bikes here, and the bikes are for different types of bikes. So here we have the deluxe touring bike silver. Let's see if we can get lucky here. Now safety, okay, we don't have, but it gives each of these by each of these groups, okay? Now if we summarize from that, so I'm going to take group by the product type. So this is now for all types of bikes, all types of water gear, and each year and month. I can summarize from that And how I'm going to summarize is the number of units. So this function in takes the number of rows, so in with the parentheses after it, takes the number of rows in each group. So here, for each product type, each year, each month, count the number of rows that are there. And I'm going to call that number of units. And we can look here at type Q. Notice there were, in 2008 January, there were 182 bikes sold. This increased to 500, and kind of averaging 400 to 500 in 2010. Okay, so then others, notice they aren't in the same range. So the others, bike pump and things like that, they're only around 100, and they increase a little bit, but not the same. So the big difference of the bikes is the bikes are the main product that they sell. Same thing with safety. Not that many safety things, maybe because people already have helmets or they buy their helmets other places, but you would think if you're buying like a mountain bike, you need a helmet. Okay, so then, and water, apparently people don't care that much about water on their bikes. Okay. So these are the, this helps us think about creating categories and grouping by those categories. Another thing you might try is binning. So here, look at the total sales again for each product. Maybe we just want to look at high price products, low price products, something like that. And so, for products that are in a month sell a lot, products for in a month that sell a little. And so I am just coming up with a kind of simple cutoff strategy here. So in this product month data frame, I'm going to create something that is called total sales size. And that is when total sales is less than 10,000, set it equal to 1. When it's between 10,000 and 50,000, set it equal to 2. So notice this between function says what is the column, what is the lower and the upper bound. When it's between 50,000 and 100,000, set it equal to 3. If it is greater than 100,000, set it equal to 4. So look at this here. And if we do the histogram of that binned number, notice we have lots of months for products that have less than $10,000 in sales. And we don't have very much in the middle two categories. In the top category, we have also similarly a fair amount of months where the product was a high selling one. So this is really saying we've got a bunch of low price products, some high price products, and those are the two most common months that have some products that sell in between. We've got a few of those products. All right, so binning, that's another option. Finally, let's talk about working with dates. So dates are just numbers, but you tell the software that they are dates, and then it stores them to show them as dates, even though it's stored as a number. So lubridate is the package in the tidyverse that we can use, and we'll use that here. So I'm going to create a second data frame from the first one and create new columns. And let me just walk through some of those columns. So in this data frame, we have month, day, or year, month, and day. So we could try and turn those into a date. Well, the lubridate has this month, day, year, year, month, day. So you could do MDY, you could do YDM. There are different ways to do this, so you can just look up the functions in the lubridate package. But month, day, year, what it is looking for is a single string that has month, day, and year together. So how to get them together? This is to concatenate columns. So paste is putting them together. So paste month, day, and year into the same column. Then tell it this is month, day, year format. And it'll try different formats, because you could have month, day, year with commas in between, month, day, year with spaces in between, month, day, year with dashes in between. Paste is going to paste numbers in between, space in between. So let me just show what this might look like. So if I do paste 2010, 1/25, oh wait, that's month, day. Notice it has a space in between, so what's getting pasted in here is spaces. Of course, to concatenate, you can also change this. You could have sep is the option there is what are you going to separate them with? So you could have a dash or something else there. Okay? So we're going to turn this month, day, year into a date. So we should see a date column come up here. You can also use functions to take out of a date a part of it. So here I'm going to use the function month to get out of a date the month. So I'm going to call this M2, same thing, take out the day, take out the year. We can also do calculations with dates. So here I'm going to do the difference between the date that there currently is, and then notice here I'm going to do year, month, day, and my input is going to be 2005-01-01, so January 1st, 2001. So what is the difference between the current date and this 2005 date? So run this, and let's look in that DTA2 and look at the last columns. We see now I have a date, and it says, well, let's look here. You can look over here. Date is a date format. So notice the others are numbers. So up here, integers, characters, numbers. Well, here now it's in a date format. You could have it be input as a character format and not recognize it as a date, so then we could have to change it to date, but this is moving it to a date. And then notice these numbers, it's pulled out January here of this January month, January 5th of this 5th here, and it, each of these, and then it gives you the difference in days here. So from January 1st, 2005 until January 5th, 2008, that was 1,099 days. Okay, so we might use these for different types of, creating different types of features. All right, so that's a lot of different feature information to throw at you. We're going to now, after this, start to practice creating the features, thinking about what features we want, and dealing with outliers and other anomalies in the data.